This is 2.5 functions day 2. We're going to continue talking about how to tell if a function is even, odd, neither, where it's increasing and decreasing. And today we're going to add in the end behavior of a function. So our warm-up, we're going to start by kind of reviewing what we did on 2.5 day 1. Determine if this function is even, odd, or neither, and state the intervals where it is increasing and decreasing. So remember our test, we have to put in a negative x for all the x's to see what happens. And even if you can visually see without writing down the test, I will expect you to actually show the test, so make sure you're comfortable writing it all down. So we have x squared, because a negative squared is positive. We didn't have an x with this one, so that doesn't change anything. We're going to compare our results to our original, and they're exactly the same. So exactly the same means even. Remember, that means that it's symmetric to the y-axis. All right, then we want intervals that are increasing and decreasing. So we need to know where any max or minimum values are. So we have to graph it. You can use a graphing calculator or graphing software. That part doesn't matter. Here's a look at our graph. We have this point down here. And if you know transformations well, you'll know that it just went down 5. But you can also use this to double check. Second calc minimum is 3. We want our left bound to be on the left side. Enter. Move my cursor to the right side. Enter. Guess. Enter. And if you remember what we talked about before, anytime you see this e to the -6, that's scientific notation telling us to move this decimal 6 places to the left. So essentially this is 0, and then that's -5. So we have the point 0, -5 on our graph here, this vertex. And so we need to talk about where it's increasing and decreasing. So this part here, these y values are getting less as we move from left to right. So this portion on the left is decreasing. So we would say decreasing is from -infinity to 0. We always use the x value to describe the interval. And we use a parenthesis because at that point, it's not increasing or decreasing. Then after we hit that minimum value, our y values start increasing again. So the second part of our graph, we would say, is increasing from 0 to infinity. So today we're going to add on to that. So we want to still be able to find if something's even, odd, neither, and where it's increasing and decreasing. But then we also want to talk about the end behavior. So when we are doing end behavior, we're going to write it in interval notation and also state the domain and range. So there's 2 things that you need to look at when you're doing end behavior. You need to look at the leading coefficient and the degree. So in this case, our leading coefficient, our LC, is 1. A lot of times I'll ask you to state what these are. And then as far as that 1 is concerned, what we care about is the fact that it's positive. Then this degree right here, so your largest exponent is your degree. Maybe I'll use a different color so we can tell what we're talking about here. So this 2 is our degree. So our degree is 2. And what we care about on that one is whether it's even or odd. So your leading coefficient, you're looking for positive or negative. And then degree, you're looking for even or odd. Might be something we want to add over here by these words. Leading coefficient, positive or negative, degree, even or odd. All right, so when we have a positive even, that tells us that we have a graph. I'm going to make a little chart for you here because there's 4 different options we could come up with. So we have a leading coefficient that could either be positive or negative, and then we have a degree that could be even or odd. So 4 different scenarios. Even positive, like we have here, tells us it's going to resemble a parabola at the ends. It may not in the middle, which we'll get to later, but the ends are both going to be going up. Even negative, both ends are going to be going down. Odd positive tells us that your graph is going to have ends going different directions, but it's going to be increasing from left to right. Odd negative means it's going to be decreasing from left to right. So those are the 4 options we have for end behavior. All right, so now the notation for end behavior. We write end behavior as x approaches infinity, f of x approaches, and we're going to fill in the blank. As x approaches negative infinity, f of x approaches, and we're going to fill in the blank. So every time you do end behavior, you will have all of this there every time. The only thing that's going to change is what's going to be after the arrows of the f of x. Okay, so remember we said that this one was an even positive. So we're looking at this type of graph right here. So if we start kind of in the middle-ish, and then we go towards infinity with our x, as our x goes to the right, what's happening with our y values? Well, our y values are going up. They're going towards infinity. And then if we start here kind of in the middle, and we go towards negative infinity on our x-axis, on our imaginary x-axis, what's happening with our y values? Well, our y values are going up, so they're going towards infinity. So both of these ended up being infinity. All right, so now we need domain and range. Well, that's going to take us back to, we need to know specifically about this graph right here. And last time we looked at this same graph, and we determined that its vertex, or its minimum point, was located at 0, 8. And that's going to be important. So domain-wise, remember domain is your x values. Your x values are going to go forever to the left and forever to the right. Those arrows make it go. So that's easy, negative infinity to infinity. But range, if you look at this think of it on a coordinate grid, there's this part down here on the grid is never going to have any part of the graph at all. And if you're a visual person, maybe I'll even put those axes on there for you so you can see what we're talking about here. So here it is at 0, 8, this minimum point right here. Notice this whole part of our graph is never going to have any part of this function on it. So our range doesn't start until we get to here. And range is the y values. So we would say 8 to infinity. Okay, that was a lot of information, but let's see if we can put it to use on a couple other examples. Good thing it's a video, so you can always go back and look at that chart if you didn't get it written down. So here we have x cubed minus 5x. Remember, the 2 things that we're looking for are leading coefficient and degree. So our leading coefficient in this case happens to be a 1. Remember, we don't necessarily care about the number itself. What we care about is if it's positive or negative. And in this case, our leading coefficient is positive. Then we also want to look at the degree. Remember, degree is our biggest exponent. And in this case, we care if it's even or odd. And in this one, it happens to be odd. So if you look at your chart, a positive odd graph will have their ends going different directions, but will be increasing from left to right. So I always state the leading coefficient, state the degree, and then I sketch myself a graph of the general shape. So my end behavior, remember it always starts with, as x approaches infinity, f of x approaches blank, and as x approaches negative infinity, f of x approaches, and we have to fill in that blank. But those two parts will always be the same. Okay, so let's go over and see. As x approaches infinity just means as you go to the right. So as we move to the right, what's this end doing? Well, this end is going up. So it means it's going towards positive infinity. And as x goes to negative infinity just means as you move from the middle to the left, what's happening to your graph? Well, your graph's going down. So it's going towards negative infinity. Domain and range on graphs like this are pretty easy because they're continuing to the left and the right forever. So negative infinity to positive infinity. And they're also going up and down forever. Again, negative infinity to positive infinity. In the computer, you use INF instead of infinity. All right, last one. See if you can identify the leading coefficient, the degree, what it all means, sketch a graph, and then write that in behavior. So hit pause, try it out, and come back. All right, so in this case, our leading coefficient is 3, which is positive. And our degree is 2, which happens to be even. So positive even tells us that we have both ends going the same direction. And in this case, since it's positive, they're going up. So our end behavior, we would have as x approaches positive infinity, f of x is going towards positive infinity. And as x approaches negative infinity, f of x approaches negative infinity. For the domain, we can tell that it is going to be negative infinity to positive infinity for all these x values. But the range, we would need to know what this bottom point is. And this was one that we found the minimum in our previous lesson. This minimum here was 1, -3. So that means our y values are going to start at -3 and go forever to infinity.